Hello again, my name's Gavin Shaw. I work for Campbell Scientific here in Australia, and in this video I'm going to be taking you through the CR1000 wiring panel and explaining what some of the different channels on the panel do. So the first one we're going to have a look at are these analog input channels. They are labeled 1H to 8L. They are for measuring voltage sensors. So any sensor that outputs any kind of voltage, they will go into our analog input channels. They can measure 0 to 5 volts. Now these analog input channels can be measured either in a single-ended arrangement or in a differential arrangement. So there are 8 differential channels, or there are 16 single-ended channels. Now a differential measurement means that you're going to wire in 2 wires from your sensor into an H and an L and measure the voltage between them. A single-ended measurement, you wire in 1 wire into an H or an L, doesn't matter which one, and you wire a signal reference wire into one of the grounds. Now differential measurements have better noise immunity, they have more precision, they're a better measurement than a single-ended measurement. However, if you go for single-ended measurements, you can fit twice as many sensors on your data logger, so that's the trade-off. Now in terms of the grounds, if you're wiring in a signal reference wire, there are 2 different types of grounds on the wiring panel. There are analog grounds, which are represented by this analog ground symbol, and there are power grounds, which are represented by a G. So analog grounds are intended for signal references. Anything that doesn't return a current should go into an analog ground. Any wires that do return current need to go into a G. So if you're powering a sensor from 12 volts and ground on the logger, the power return needs to go into a G. If you're performing a single-ended measurement with respect to a signal reference wire, that goes into an analog ground. Now in terms of the types of sensors that you can connect to these analog inputs, thermocouples output a voltage, a lot of water level sensors will output a voltage as well, 0 to 5 volts. The HMP45 and the HMP50, those are temperature and RH probes, they also output a voltage. So there's some of the sensors that we connect to our analog inputs. Alright, so the next lot of channels that we'll have a look at are our analog output channels. So we had a look at our analog input channels. They measure a voltage very accurately between 0 and 5 volts. The analog outputs do the opposite. They will output a voltage between 0 and 2.5 volts this time, very accurately. So we need to use these for resistive measurements. The data logger doesn't have a way of measuring resistance directly, so instead we excite the resistance with a known voltage, which we get from our analog outputs, and then we measure a voltage that comes back from the sensor using our analog inputs. So some examples of resistive sensors are 107, 108 and 109 probes. Those are soil temperature probes. They have a resistance that changes with temperature. Our 03301 RM Young wind vane, that has a resistance which changes with wind direction. So those type of sensors that have resistive elements to measure, they will need to use both an analog output and an analog input. Alright, so next up are our pulse counting channels. These are labeled P1 and P2. As the name suggests, we use these to measure sensors which output a pulse. There are 3 different types of pulses which we measure with the CR1000. The names we give to them are switch closure, for sensors which literally close a switch inside them, and we measure how many times that switch closes. Low level AC, that's for sensors which output a sine wave, an alternating current wave or an alternating voltage wave. And high frequency is the 3rd option that we have in the logger. And high frequency are sensors which output 0 to 5 volt pulse. Now some examples of those sensors, a tipping bucket rain gauge is probably the simplest. That has a switch on board which closes each time the bucket tips. We measure those pulses with a pulse counting channel. The 03101 is a wind speed sensor from RM Young that outputs a sine wave, so we use low level AC. The 034B is a MET1 wind speed sensor that outputs a switch closure, so again on our pulse counting channels. And finally, probably another one of the common sensors we have is a shaft encoder, which measures water level. Now that outputs a 0 to 5 volt signal, so that'll also go into a pulse counting channel, this time high frequency. Now the last group of channels we're going to look at are our control ports. They are on the bottom terminal strip on the wiring panel. They are labeled C1 to C8. So these don't really measure sensors, they're more used for control of sensors or control of other devices. So they're called digital I/O or digital inputs or outputs. So the digital part means they're only ever in one of two states, either high, which is 5 volts, or low, which is 0 volts. Now using these we can do things like turn relays on and off. So relay is a little device that takes a 0 to 5 volt signal and closes a switch based on that signal. So using that we can use a low voltage, 5 volts, to turn a switch to power things that require higher voltages like 240 volts AC or something like that. So very useful for relays for turning larger devices on or off. You can also use these control ports to turn LEDs on or off. So you can have an LED on the outside of your enclosure to indicate if there's a problem with your sensors or something like that. You can use a control port to turn that on or off. Now another use that we're using more and more these days is that we can use a pair of control ports to connect a cable to the CR1000, which will give us another RS232 port to connect to. So we're going to have, in the future, we're going to do a whole video on how to do that because it is very useful. You can use that to connect your modem to control ports rather than RS232 port and leave that port free for site visits or for techs to connect their laptop to. So control ports are very useful. They're mainly used for control, hence the name. They're not really used to measure any sensors. Okay, so that's a bit of information about the 4 different types of channels that we have on our data logger. We have a video out at the moment to show you how to use Shortcut to program for different types of sensors, so definitely check that video out to have a look at the programming side of the data loggers. In the coming months we're going to try and bring out more and more videos focusing on specific sensors. So the type of sensors that I've gone through in this video, we're going to try and get videos out for those, things like the HMP45 and the HMP50, soil moisture, soil temperature, all of those sort of sensors. We'll try and get some videos out to show you how to program and how to wire those. In the meantime, if you're looking for wiring advice, check out our multiplexer video. We show you how to wire up a multiplexer and connect more sensors to your CR1000. Alright, well thanks for listening, and I'll see you guys next time.